You know soy sauce, right? It's in pretty much every kitchen, that go-to for the perfect savory kick. But behind that familiar dark liquid, there's a hidden world. It's a story of microscopic collaboration and competition that turns a few simple ingredients into a global flavor powerhouse. Okay, let's get into it.
At its heart, yeah, this is what we all know soy sauce to be. It's salty, and it's got that deeply satisfying, savory flavor we call umami. This definition from way back in '83 really nails the experience, but it barely, and I mean barely, scratches the surface of how that flavor gets made.
And that really is the big question, isn't it? How does something so basic end up creating something so incredibly complex? The answer isn't in a simple recipe you can follow at home. It's all about a microscopic, multi-stage fermentation process that's been perfected over centuries.
And here they are, the four humble ingredients that start this whole journey. You've got soybeans for protein, wheat for sugars, salt for preservation, and crucially for choosing the right microbes, and water to bring it all together. Seems pretty simple, right? Well, this is where the magic, or, the science really begins.
The first act in this flavor drama is called the koji stage. This is where the raw materials get prepped for their epic transformation. It's where it all kicks off. So, what's actually going on here? First, the soybeans get soaked and cooked. This doesn't just soften them up, it also lowers their pH, which helps keep bad bacteria away. At the same time, the wheat is roasted to develop some flavor, and then it's ground up. Then comes the most important part. The two are mixed together, and a very special mold is added. Then they just let it hang out and incubate for about 3 days.
Let me introduce you to the star of Act 1, Aspergillus oryzae. This is that special mold, also known as koji mold. It's the primary engine of this whole first stage, and without it, the process would just stall out before it even got started. A good way to think of Aspergillus oryzae is the first shift worker in a flavor factory. Its entire job is to get everything prepped for the next team. It produces this whole toolkit of powerful enzymes that just get to work, breaking down the big complex molecules in the soybeans and wheat. Proteins get chopped up into amino acids, that's where umami comes from, and starches get turned into simple sugars, which is basically lunch for the next set of microbes.
All right, now for stage 2. The koji, which is now packed with enzymes and pre-digested nutrients, gets moved to a completely new environment. This is the moromi stage, and it's where our koji mash gets submerged in a super concentrated salt brine.
So how does this part work? Well, first, that finished koji is mixed into a brine with a salt concentration of around 18 to 22%. That is incredibly salty. So salty, it actually kills off the koji mold and most other unwanted microbes. But it creates the perfect playground for a new team of salt-tolerant bacteria to take over, kicking off lactic acid fermentation. As they produce acid, the whole environment changes again, paving the way for the final crew, the yeasts.
And here's the main player for the second act, Tetracoccus halophilus. This is our key lactic acid bacteria, a true specialist that absolutely loves the high salt conditions of the moromi mash. This bacterium is a real champion of harsh environments. It gets to work right away, munching on those simple sugars the koji mold made and producing lactic acid as a result. And the effect is pretty dramatic. It lowers the pH of the mash, taking it from a neutral 7 all the way down to a much more acidic 5.
This is where you see it's not just a simple handoff, it's a dynamic step-by-step takeover. One group of microbes literally changes the environment, making it unlivable for themselves, but absolutely perfect for the next team waiting in the wings. It's this beautifully orchestrated microbial tug-of-war, and this battle is what's essential for creating that complex flavor.
And that brings us to the final major player in our microbial drama, the yeast, Zygosaccharomyces rui. When that pH drops, it's basically a signal for this salt-tolerant yeast to step into the spotlight.
Just like the bacteria before it, this yeast is a salt-tolerant specialist. It waits patiently until the lactic acid bacteria have done their job and brought the pH down below 5. Once the conditions are just right, it starts to dominate, consuming the rest of the sugars and producing alcohol and a huge range of the aromatic compounds that give soy sauce its unique smell.
And this, right here, just illustrates that microbial relay race perfectly. On the left, you've got the bacteria, which thrives at a higher pH. Its own action, making acid, lowers that pH and eventually stops its own growth. But in doing that, it passes the baton to the yeast on the right, which needs that lower pH of 4 to 5 to really get going. It's a perfect example of microbial succession. So after months, sometimes even years, of this complex dance, what's the result? Well, the final flavor is the sum of all these microbial parts. It's a symphony of compounds created at every single stage.
Let this number sink in for a second. 300. What could that possibly refer to in a simple bottle of soy sauce?
That's right. Researchers have identified nearly 300 different aroma compounds in the final product. Every single one is a tiny piece of the flavor puzzle, a little signature left behind by the molds, bacteria, and yeasts that did all the work.
So why does any of this matter? Because this incredible microbial relay race is the very source of soy sauce's complexity. All those alcohols, esters, acids, and other compounds all add up to create the final product. Without this intricate, microscopic flavor factory, let's be honest, soy sauce would be little more than salty brown bean water.
And all these fascinating details we've explored today, they come from a deep dive into the science. This whole explainer is based on a comprehensive review of soy sauce fermentation from researchers at the University of Birmingham, which was published in Food Research International. It really makes you think, doesn't it? The next time you splash some soy sauce on your food, you'll know the secret story, that there's a microscopic world that worked for months to create it. And that just leaves us with one final question. What other everyday foods are hiding their own secret microbial worlds?